Hi everyone, let us discuss this example. So in this example we have this equation and we have to prove that it has three solutions in that interval minus 4 comma 4. Okay, so let us start to discuss this example. See, whatever the polynomial we have, we call it as f of x, that will be our function. So let f of x is equal to x cube minus 15x plus 1. So this is our function, okay, and f of x is equal to 0. This is the equation and we have to find it has the solutions in this interval minus 4 comma 4. So what will I do? I will draw the diagram so we can easily understand the concept. Okay, so let me show it here. This is a real line. 0 we have 1 2 3 4 minus 1 minus 2 minus 3 minus 4. Okay, to solve this example we are going to use Bolzano's theorem. But that theorem has a specific condition. If that condition is satisfied, then only we can apply Bolzano's theorem. That condition is function must be continuous. Okay, so let us check whether the given function is continuous or not. As you can see here, this is a polynomial function and we know that every polynomial function is definitely continuous on real line R. Okay, so let me mention that thing. This is polynomial function implies f is continuous on R. Okay, actually we want function should be continuous on this interval, but it is continuous on entire real line, so definitely it is continuous on that interval also. So this function f satisfies okay, the condition of Bolzano's theorem, so that's why we can apply Bolzano's theorem. Okay, first of all, what will we do? We will try to find the values of f. We are going to find values of f at all these integers, right? Minus 4, minus 3, minus 2 and so on. Let us start to do. So consider f of minus 4. Okay, so here we have to put minus 4 cube minus 15 minus 4 plus 1. So minus 4 cube is minus 64 minus plus 60 plus 1. The sum is minus 3. The sum is what? Minus 3. Actually we are not interested in value, we are interested in its sign. It has a minus sign. So that's why we get a negative value here. Getting? So at minus 4 we get a negative value. Let me mention it here. So we are having a negative value at minus 4. Okay, so let us find the value at minus 3. F of minus 3. F of minus 3, that means at the place of x we have to put minus 3. Minus 3 cube minus 15 minus 3 plus 1. It is minus 27 plus 45 plus 1. So it will be just a minute, let me find. So 45 minus 27, it will be 18, right? Plus 1, 19. Yes, it is 19. Okay, so it's a positive. So at minus 3 we get a value 19. So we are having a positive value here. Okay, so Bolzano's theorem says if you have a negative value for some point and if you have a positive value for next point, then definitely there is some point between minus 4 and minus 3 where the function has solution. Getting? Solution. So that means at minus 4 we have a negative value, at minus 3 we have a positive value. So definitely that continuous function cuts that x-axis. So that's why we say it has a solution between minus 4 and minus 3. So let me mention it here. Let me mention that thing here. Therefore, by Bolzano's theorem, f of x is equal to 0 has solution between x is equal to minus 4 and x is equal to minus 3. Okay, so let us go further. Okay, so between these two we got a one solution. How many solutions we want? We want 3 solutions. So out of them I got one solution here between minus 4 and minus 3. Let us go further. I will do the same for minus 2. F of minus 2, let us put x is equal to minus 2 here. So I will write directly now. So it is minus 8. This is plus 30 plus 1. So it is 23. Okay, so the positive. So at minus 2 we have a positive value, positive, negative, positive. We got solution between opposite signs, positive, positive. You will not forget any solution between them, okay, hopefully. So f of minus 1, I am finding the value at minus 1. So let us put x is equal to minus 1. Minus 1 cube is minus 1, minus minus plus 15 plus 1. So it is 15. Again we are having a positive value, right? So let me mention here we have a positive at minus 1. Let us find at 0. F of 0, 0 cube is 0, 0 plus 1. So 1, again positive. So that means at 0 also we have a positive value, right? Yes. Let us find at 1. So f of 1, let us put 1 here. 1 minus 15 plus 1, right? So it is minus 13. Negative. See, we got a negative value here, right? Negative. So here we have positive, there we get a negative. So again Bolzano's theorem says there is a solution between 0 and 1. So therefore, by Bolzano's theorem, f of x is equal to 0 has solution between x is equal to 0 and x is equal to 1. Yes, second solution we got. We want 3 solutions, we got 2 solutions. Now let us go further. Find f of 2. F of 2, 2 cube is 8, minus 30 plus 1, so it will be minus 21, negative. Okay, so at 2 we have a negative value. Let us do for the same, for the f of 3. Let us find. So it is 27 minus 45 plus 1. So it will be 45 minus 28. So it will be minus 70, negative. Again we have a negative value here, right? So negative. Okay, so last point 4. So f of 4. So that means here I should put 4. 4 cube is 64 minus 60 plus 1. So it is 5, positive. So at 4 we have a positive value again, getting. So here negative, positive. So again I can apply Bolzano's theorem, and that theorem says there is a solution between x is equal to 3 and x is equal to 4. That will be the last solution, since already we have got 2 solutions, right? How many solutions we want? 3 solutions, and the third solution we get between x is equal to 3 and 4. Let me write it properly, make a screenshot of it first, then I will go further. So let me write it here. So therefore, by Bolzano's theorem, f of x is equal to 0 has solution between x is equal to 3 and x is equal to 4, right? 3 and 4, between 3 and 4 we get a solution. So in this way we got 3 solutions. So let me mention here, therefore f of x, which is our f of x is x cube minus 15x plus 1 is equal to 0, has 3 solutions in interval minus 4 comma 4. In this way we finish. Okay, make a screenshot of it, then we will stop. Thank you. Bye bye.